So right now we're going to relate a position versus time graph to a motion map. So right here on the left, we have a position time graph with a time from 0 seconds up to 8 seconds. The position scale goes from 0 to 4 meters. The motion map, this number line that we see over here, it's labeled from 0 meters to 5 meters. Now, the number line here is going to tell us our position, which we represent with the letter X when we're talking about horizontal motion, or the letter Y if we're talking about vertical. I'm just making the assumption that this will be horizontal motion. So the way that we set this up is we are going to be representing the position at even increments of time. Just to make it easier for me, I'm going to say that those even increments of time will be 1 second intervals. So on my position time graph, I see at a time of 0 seconds, the position is 0 meters. So I'm just going to put a dot that aligns with my number line at a position of 0 meters. This is where the object starts. Then 1 second later, on the position time graph, at the coordinate 1, 2, that's a time of 1 second, it's a position of 2 meters. So I'm just going to put another dot at that position. Then at a time of 2 seconds, it's at a position of 4 meters. At a time of 3 seconds, it is still at 4 meters. Now I can't put a dot directly over the previous one, otherwise it wouldn't be kind of clear that it was staying still. So whenever that happens, I just put a dot at the same position on the number line, but just above or below it. Then at 4 seconds, the object is a little bit past 3 meters, so I will show that there. Then at 5 seconds, looks like it's about 2.5 meters. At 6 seconds, 1.67. 7 seconds, I don't know, like 0.7. And then back at 8 seconds, it's down to 0. This is where it ends, so just to make sure that I know that that's where it ends, I cross it out, and then I write down the word end. Now, the dots represent the positions, but just so that way, particularly if we didn't have the words here, so we could follow along with the trend of it, I recommend drawing an arrow pointing from one position to the next. Now, while we could just connect the dots and add arrowheads there, I find that gets a little bit messy. So my general rule of thumb is to use half of the distance between each object to show that at the beginning, from 0 to 2 seconds, the object is increasing its position. So that's a time of 0, 1, and then 2, and then starting at 2 seconds, it is not moving for 1 second, and then at a time of 3 seconds, it starts moving back in the opposite direction. Now, I can't put an arrow on that very last point, because I do not know if it's going to continue that trend or not. That's why I just cross it out and put the word end there. Now, this is really all we need for a motion map. Realistically, you can even get away without using the words, just to show that, hey, as long as we see the arrows, we can follow along with that trend. I do like to indicate the change of time of 1 second, just so that way we know how much time has passed. You can change that to 2 seconds, half-second intervals, whatever you want, as long as it is clearly communicating the motion of the object. Now, one thing I'm also going to add here is just going to be time labels, not necessary for a motion map, but it is helpful for kind of organizing and ensuring we know what time corresponds with which position. So we start off at a time of 0 seconds, and then it's 1 second, 2 seconds, 3 seconds, 4, 5, 6, 7, before finally ending at 8 seconds. Now, a very common mistake is when we're talking about that very first point. A lot of people just instinctively say, that is our first time, 1 second. But our time observations will start off at 0 seconds, so that's where it should always begin.